Okay, so the next question that we have is you want to show that the equation of the line passing through the origin, so that there's a line passing through the origin 0, 0, and making an angle theta and making an angle theta with the line with the line y is equal to mx plus c is y divided by x is equal to m plus or minus tan theta over 1 plus or minus m tan theta. 1 plus or minus m times tan theta. So you want to prove this, and of course this is something something of course interesting and useful, meaning that you have any line y is equal to mx plus c, and if the line goes through, for example, let's say that for example you have this line over here, and there is a line that goes through the origin, and of course intersects with this line as well. So let's say that this is y is equal to mx plus c, and this line goes through the origin and makes an angle of, now theta could be this angle theta you have basically two angles over here, meaning that this angle is equal to this angle and this angle is equal to this angle over here. So I suppose with theta the acute angle is meant because through the process that we would normally use in order to get this equation, we are using the relationship tan of theta is equal to the absolute value of m2 minus m1 over 1 plus m1 m2, I suppose. That's the only thing that comes to mind, or at least based on what we know so far. So based on what we know so far, that's basically the only thing that the only relationship that we know that can show us basically the slope of two lines and the relationship of those two with the angle between two lines, and that angle is the acute angle. So the same tan theta comes over here and it basically adds up to this formula. So then I suppose what that means is that then basically this theta over here is the acute angle between these two lines. And so what that means is that if you have then this line y is equal to mx plus c, and if you have any other line that goes through the origin and has basically intersects with the first line, making an angle of theta with the first line, then the equation of the second line, this one over here, is going to be y over x is equal to m plus or minus tan theta over 1 plus or minus m times tan theta, which is of course something useful in many different situations. So now that's what we want to show, and it must be easy. It must be not complicated. So excuse me. So what you need to do over here is first find the Well, if you have basically a line that goes through this point, you can say that y minus y1 is equal to m times x minus x1. And if that is the point, then if this line goes through commas 0, 0, then you can write what is equal to mx, because y1 and x1 you can set them to 0 and 0, so then you will get y is equal to mx. Now if y is equal to mx, then the only thing that we need about or basically you can say that y divided by x is equal to m. So all that I need over here is basically to show that to find basically the slope of this line. And let's go over here and see what the slope of this line is going to be. So let's say that you have basically this line over here, y is equal to mx plus c, and if I call the slope of this line m1, and the line whose slope I want to find, if I call the slope of that line m2, then of course you know that and of course these two lines are going to intersect, and they are the acute angle between those two lines is going to be theta, meaning that suppose that for example you have y is equal to mx plus c over here, and the slope of this line is m1, and there is some other line that suppose that it goes for example through the origin, and it makes an angle of for example theta with this line, and if the slope of this line is m1, then the slope of this line is going to be m2, and the relationship between all of these things over here is, as you know, tan of theta is equal to basically the absolute value of m2 minus m1 over 1 plus m1 m2. Okay, so that is that. So now what that means is that of course I have no values over here to I have no values over here to substitute there is one piece of information that I don't have. I mean, I do need to have one more piece of information so I can decide the whole thing, but I don't have it. Meaning that based on this, I should be able to figure out what M2 is and then put it in, for example, M2 and then put it in y is equal to mx and find the equation of the line. But then the only way that you have to, basically the only way that you could figure out this whole thing is that basically you could say that, for example, well, we could of course solve this equation, meaning that we could say that m2 minus m1 over 1 plus m1 m2, 1 m1 m2 is equal to plus or minus tan theta. That we could do. And then m1 m2, and then I can say that And then I can say that basically if basically either m2 minus m1 over 1 plus m1 m2 is equal to tan theta, or m2 minus m1 over 1 plus m1 m2 is equal to negative tan theta. And in this case I have m2 minus m1 is equal to tan theta basically plus m1 m2 tan theta and then I can take this to the other side of the equation. m2 minus m1 m2 tan theta is equal to m1 plus tan theta. So m2, take this to the other side, minus m1 m2 tan theta is equal to m1 plus tan theta. From this, if I take m2 out, m2 is equal to, I'm sorry, there is no equal to, m2 times 1 minus m1 tan theta, m1 tan theta is equal to m1 plus tan theta. So m2 times 1 minus m1 tan theta is equal to m1 plus tan theta. So here m2 is equal to m1 plus tan theta over 1 minus m1 tan theta. So this is one, basically this is one equation for m1 or for m2. Or if basically if this is the case with the equation, you can write m2 minus m1 is equal to negative tan theta minus m1 m2 tan theta, which means that m2 plus m1 m2 tan theta is equal to negative tan theta plus m1 and so if I take the m2 out, I will get if I take the m2 out, I will get m2 times 1 plus m1 tan theta is equal to m1 minus tan theta. So m2 is equal to m1 minus tan theta, 1 plus m1 tan theta. So these are the two different slopes that we get for that line. And so we can write plus minus 1 m1 tan theta m1 1 so I can from this I can say that m is equal to basically m1 if you have a negative over here, you have a positive over here, so tan theta, and over here I have m1 tan theta. If you have a negative positive, and if you have a positive, you have a negative over here. So that's why what I wrote up here is actually not correct. This is not simply plus or minus. It's negative positive or or basically minus plus plus minus. So then I can say that, and then we said that basically the equation of the line was y is equal to mx, because it does go through the origin. It does go through the origin, so that means that I can write y is equal to basically this whole thing over here, m1 minus plus tan theta, 1 plus or minus m1 tan theta, times x, and then I can say you can divide by x. Basically you will get y divided by x is equal to m1 minus plus tan theta over 1 plus minus m1 tan theta, and that is the equation of a line that goes through the origin and makes an angle of, that is the equation of the line going through the origin, and and making an angle of theta with the line y is equal to mx plus c. That is basically that. Okay, so that was question number 13. We have basically question number 14, 15, 16 through 24. So we will do these questions one by one. Okay, so the next question is find the distance of. Okay, so the next question is number 14. In what ratio the line joining basically these 2 points, we have basically 2 points over here, negative 1, comma 1, negative 1, comma 1, and 5, comma 7. There's a line joining these 2 points. So basically, in what ratio this line is divided by the other line is basically, if I call this line number 1, is line 1 divided by the line x plus y is equal to 4. So basically what we have over here is, this takes a little bit of work, but it's an interesting example. So you have these 2 points, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, and there is this point over here, 5, comma 7, and there is another point, negative 1, comma 1, and there is a line, there is a line segment, we could say, negative 1, comma 1. So there is a line segment joining these 2 points. Now in what ratio is this line divided by this line? So this line is basically y is equal to negative x plus 4. negative x plus 4. So negative x plus 4 is basically 1, 2, 3, 4. This is 1 point on the line. This is the y-intercept, and basically the basically the slope is negative 1. So now you want to know basically in what ratio is this line, for example, let's call it L1, and this is let's say L2 and L1. In what ratio L2 is divided by L1, or if I call these points, for example, A and B and M, you want to know the ratio. You want to calculate the ratio AM to, for example, MB. You want to know what this ratio, what this ratio is. So what you need to do is first find the point of intersection of these two lines, which is basically this point over here, and then use the distance formula to find the distance between these 2 points, and then again find the distance formula to find the distance between these 2 points, and then those two distances become AM and MB, and then form a ratio of those two, and then that's basically your answer. So this line over here, which is x plus y is equal to 4, this is x plus y is equal to 4. I already know the equation of this line. So let's find out what the equation of this line is, and then we will find out the point of intersection of the two. So what I'm going to do is basically I have these points negative 1, 1, and I have 5, 7. So the slope over here is y2 minus y1 over x2 minus x1, which is equal to 7 minus 1 over 5 plus 1, which is equal to 6 over 6, which is equal to 1. So the slope of this line is 1, and the slope of this line is negative 1. So the angle between them must be a 90-degree angle. But, well, that's not really important here. So what that means is that now the slope is 1, and then I can say that I can write y minus y1 is equal to m times x minus x1. So take this point, for example, y minus 1 is equal to 1 times x minus x1, which is x plus 1. So that means that y is equal to x plus 2. That is that this line over here is y is equal to x plus 2. Y is equal to x plus 2, and that is the equation of this line. Now let's find out what the point of intersection of these two lines is. So we have x plus y is equal to 4, and negative x, and this line would be negative x plus y is equal to 4, or you can say x minus y is equal to negative 4. X minus y is equal to negative 4. Negative x plus y is equal to I made a mistake over here. I'm sorry. No, I made a mistake over here. So this line over here is y is equal to x plus 2. So then you can write basically negative x plus y is equal to 2, or x minus y is equal to negative 2. So you can write x minus y is equal to negative 2. Now you have a system of equations. So if you add these two equations together, you'll get 2x is equal to basically 4 minus 2 is equal to 2, so x is equal to 1. And then use any of these equations. X plus y is equal to 4, so 1 plus y is equal to 4. So y is equal to 3, which is 1 comma 3, this exact point over here, 1 comma 1 2 3 over here. So this point over here is 1 comma 3 exactly. So now the point, basically the distance formula is AB is equal to basically the square root of x2 minus x1 whole squared plus y2 minus y1 whole squared. So then AM, basically AM is equal to, A is negative 1 comma 1 and M is 1 comma 3. So then you can write this as basically 1 plus 1 whole squared plus 3 minus 1 whole squared, and that is equal to the square root of 2 squared plus 2 squared, the square root of 4 plus 4 plus 4, 2 squared is 4, so this is 4, so that's the square root of 8, which is equal to 2 square root of 2, because 4 is 2 times 4, which is equal to 8, so 2 square root of 2. So that means that AB is equal to, AM is equal to 2 square root of 2. Is equal to 2 square root of 2. 2 square root of 2. Now BM, the points are basically 5 comma 7 and 1 comma 3. 1 comma 3. So you can write this as basically 1 minus 5 all squared plus 3 minus 7 whole squared, which is equal to the square root of negative 4 squared, negative 4 squared, and that's basically 16 plus 16, that's the square root of 32, which is equal to the square root of 2 times 16, which is equal to 4 square root of 2, which is equal to 4 square root of 2. And so BM is equal to 4 square root of 2. 4 times square root of 2. So now the ratio in which this line has been divided is, for example, AM to BM, which is equal to 4 square root of 2. My 4s are not very good. So AM is equal to, 2 square root of 2. AM is equal to 2 square root of 2, and BM is equal to, it seems that I'm making a whole lot of mistakes. BM is equal to 4 square root of 2. So square root of 2, square root of 2 cancel out. Doesn't, okay, 1 to 2 does make sense. Okay, so this is 1 to 2. 1 to 2. So that means that AM to BM is equal to 1 to 2. That is the ratio. That is the ratio. That was number 14. 1 to 2. Okay, so the next question that we have is number 15. Find the distance of the line from the point along the line. Okay. So we have you want to find number 15, you want to find the distance of the line. Find the distance of the line 4x plus 7y 4x plus 7y plus 5 is equal to 0 from the point 1, 2 along the line 2x minus y is equal to 0. That means that this point must lie on this line. Otherwise, let's see, 2 times 1 minus 2 is equal to 0. 2 minus 2 is equal to 0. That is right. So this point actually lies on this line. So now what we have over here is basically this situation. You want to find the distance of this line, which is basically 4x plus 7y plus 5 is equal to 0. You can write this as 7y is equal to negative 4x negative 5, and y is equal to negative 4/7 x minus 5/7. And so what that means is that negative 5/7 is somewhere over here. So negative 5/7 is your y-intercept, which is some point over here. And negative 4/7 is for 7 units of horizontal change. You have negative 4 units of vertical change. So it means that 1, 2, 3, 4, 5, 6, and 7, negative 4. So negative 4 would be 1, 2, 3, and 4. So you would be basically 1, 2, 3, and 4. So you would end up over here somewhere. So this is the graph of the line 4x minus 4x plus 7y plus 5 is equal to 0. Now there is a point over here. 1, 2, which is this point over here, and there is a line over here, 2x minus y is equal to 0. 2x minus y is equal to 0. So that means that negative y is equal to negative 2x, y is equal to 2x. This is a line going through the origin with a slope 2. So that means that you will go exactly through this point and down here. And so this point over here is 1, 2, and this line over here is 2x minus y is equal to 0. And of course this, as you know, is the x-axis, and this over here is the y-axis. This is the y-axis. And these are of course lines. You already know that. Normally you should basically show that they are lines. And so what that means is that now you want to know basically the distance of this line, from this point along this line. You want to find out this distance over here. So it's not that complicated. If you find the point of intersection of these two lines, which is this point over here, and then you can find the distance of these 2 points. So then I have 4x plus 7y plus 5 is equal to 0, and 2x minus y is equal to 0. Call this, for example, 1 and 2. If I multiply 2 by 2, I will get 4x plus 7y plus 5 is equal to 0, and 4x minus 2 minus 2y is equal to 0, and then negative, positive. Subtract this from this. These two will cancel out. 7y plus 2y is equal to 9y plus 5 is equal to 0, so y is equal to negative 5/9. And then take any of these equations, for example 4x minus 2y is equal to 0. So then 4x is equal to 2y. 4x is equal to 2y, or I can simply take a better equation, meaning I can take this one. 2x is equal to basically y, so negative 5/9, negative 5/9 So negative 5/9 is equal to 2x. That means that x is equal to this divided by 2, which is negative 5/18. So this point over here, the coordinates of this point are basically negative 5/18 and negative 5/18 and negative 5/9. So now that I have the 2 points, I can find the distance of the two. I can find the distance of the 2 points. Again, we said that the distance formula was the square root of x2 minus x1 whole squared plus y2 minus y1 whole squared. And that is equal to, basically over here I have these 2 points, 1, 2, and negative 5/18 and negative 5/9. So then I have basically negative 5/18 minus 1 whole squared plus negative 5/9 minus 2 whole squared, and basically then we have this we can figure out what this is, so we can write this as negative 5/18 negative 18/18 whole squared plus negative 5/9 negative 18/9 whole squared and then we can do this calculation. Negative 5/18 negative 18/18 is negative 23/18 negative 23/18 whole squared plus negative 23/9 whole squared, and take the square root of that. And there's some trouble here. I have to raise all of these to the second power, so 23 times 23 is equal to 960 or 0, I'm sorry, 0. And so 9 and 6, 2 times 3 is equal to 6, 2 times 2 is equal to 4, 9, 12, 1, and that's 529. So 23 squared is equal to 529. So that is the square root of 529 by, and negative squared is positive, of course. Then you have 18 squared. 8 times is equal to 64. 14, 18, 4, basically that is 12, 1 and 324. 324 plus 23 squared is equal to 529 over 81. 81. And then this is equal to well, 324 must have some factor of 81. I suppose so. So if I write 324 is equal to divide by 2, you will get 150, and 20 divided by 2 is equal to 10, and that is a 2. So you'll get 2, 662, so that's 2 times 162, and that's 81. 2 times 81. So you see it's 4 times 81. So I can write, well, I can simply write, so 324 is the same thing as 4 times 81. 4 times 81. So I can write this as the square root of basically 324, 529, and 324 divided by 81 is equal to 4. So 4 times 529. 529 times 4 is equal to 36. 8 plus 3 is equal to 11. 1. 8 plus 3 is equal to 11. 1. And 21. 2116. 2116. And then 2116 plus 529 is equal to 15. 1. That's a 4. That's a 6. That's a 2. And that is equal to basically 2645. 2645 divided by 324. Now, as we said here, 324 is 4 times 81. When you take the square root of that, you would get 2 times 9, which is equal to 18. So that is 18 squared. So 324, that is equal to 18 squared. But about this number, 2645, I suppose we can use a calculator to save some time. The square root of 2645 is 23 square root of 5. So I can write this as basically 23 square root of 5 over 18. 23 square root of 5 over 18. Units is the distance between the 2 points, which is hopefully the right answer. 23 by 18 times square root of 5 is the right answer. Okay, so that was basically this example over here. Next we have question number 16. Okay, so the next question is question number 16. The question is, find the direction in which a straight line must be drawn through the point -1, 2. -1, 2. A straight line drawn through this point so that its point of intersection with the line x plus y is equal to 4. The point of intersection of that line with this line may be a distance of 3 units from this point. Maybe a distance of 3 units. 3 units from the same point, I suppose. So you have a point over here, negative 1 comma 2. You have a point over here, negative 1 comma 2, and so the point is over here, negative 1 comma 2. You want to draw a line, a straight line through this point in such a way that the point of intersection of this line with this line, which is basically y is equal to negative x plus 4, y is equal to negative x plus 4, which is basically this line over here, 1, 2, 3, 4. So you have this line over here. So this is y is equal to negative x plus 4, which is basically this line over here. So that the point of intersection of these two lines is the line that you draw through this point, the point of intersection is 3 units from negative 1 comma 2. So basically what you need to do is, there is a point on this line, whose distance from from this point, so basically we had some equation or some formula that we said that x1 comma y1, if you have a point x1 comma y1 and some line some line, for example, ax plus by plus c is equal to 0, then the perpendicular distance of this point from this line was something like d, which was basically the absolute value of I don't remember what that was. The distance was basically the absolute value of ax1 plus by1 plus c over the square root of a squared plus b squared. So with this formula you can find the perpendicular distance of, for example, this point from this line, which is not going to help us. Now what we need to do is okay, so basically what I can do is that basically I already know the slope of this line. So I need to basically basically somehow calculate the slope of another line. I need to calculate some slope in such a way that you see, if I use this formula over here, tan of theta is equal to the other one over here, I don't see it right now. tan of theta basically was m2 minus m1 over 1 plus m2 m1 m2 or something like that. So we had this formula, and what this formula does is that okay, so what this formula does for me is that it gives me basically, if I give it the slope of this line and the angle between, and the angle that I want to have between the two lines, it gives me the slope of the other line. So that is also there, but that's not going to help me right now, not at least directly. So what I need to do is that I actually need to find basically what I need to do to solve this problem is that I need to find the equation of a line, the equation of some line with some slope, and I know that the line goes through this point over here, -1, 2, right? So I have some slope and 1 point on the line, and then based on, once I have the equation of that line, I calculate the point of intersection of these two lines, and that point of intersection is going to be the distance between that point of intersection and this point has to be 3 units. So that's easy to do. That's the strategy that we can use. We can basically calculate some line over here, the equation of some line that goes through, that has a slope m and goes through this point. Once I have that, I can find the intersection, the point of intersection of these two lines, and the distance between that point of intersection and this point has to be 3 units. That's basically all you need to do. So first step, I need to find the equation of the line. So I can write y minus y1 is equal to m times x minus x1. Then I can write y minus 2 is equal to m times m. I don't really know what that is. We will find out. X plus 1. So that means that y minus 2 is equal to mx plus m. And I don't really need to do much over here. Just leave it as it is. So the equation of the other line is y minus 2 is equal to m times x plus 1. M times x plus 1. That's the equation of the line that we are looking for. And so now the point of intersection of these two lines is basically let me see, x plus y. X plus y is equal to 4, and well, I need to write this in the same way, meaning that I write this as y minus 2 is equal to m times x plus 1, and so y minus 2 is equal to mx plus m, and so y is, or I can say basically, I can write this as negative mx plus y, negative m minus 2 is equal to 0. Negative mx plus y minus 2 and negative m is equal to 0. And if I multiply by negative 1, I'll get mx minus y plus m plus 2 is equal to 0. So, and I write this line as x plus y minus 4 is equal to 0. And both of the lines are now in general standard form. So mx minus y plus m plus 2 is equal to 0. And so now we can find, we have a system of equations in two variables, x and y, and then we can solve them. So if I add these two equations together, I will get basically x plus mx minus 4 plus m plus 2 is equal to 0. That means that basically x plus mx and plus m minus 2 is equal to 0. And what that means is that, so x plus mx is equal to basically 2 minus m, and x times 1 plus m is equal to 2 minus m. So x is equal to 2 minus m over 1 plus m. So this is the x coordinate of that point. And then you can use, for example, this equation over here, write it as x plus y minus 4 is equal to 0, and then put x as 2 minus m over 1 plus m plus y minus 4 is equal to 0. And then we have y is equal to 4 minus this whole thing over here. 4 minus 2 minus m time over 1 plus m, which is equal to 1 plus m, and that is 4m, that is 4 times 1 plus m minus 2 minus m. And this pair of parentheses is important. If you forget it, you will not get the right answer, because this negative sign has to be multiplied by both of these terms. You need to be careful about that. So then you have basically 4 plus 4m minus 2 plus m over 1 plus m, which is equal to 4m plus m is equal to 5m. 4 minus 2 is equal to 2. 1 plus m. That is your y. That is the point of, these two are the points of intersection of the two lines. So I'm going to write them down over here somewhere. So the points of intersection of the two lines are going to be x is equal to 2 minus m over 1 plus m, and y is equal to 5m plus 2 over 1 plus m. And that is then the point of intersection of the two lines. Now what you need to do is that basically the problem is almost solved, meaning that all you need to do is that the distance between this point and this point has to be 3 units, and the distance formula is AB is equal to the square root of x2 minus x1 whole squared plus y2 minus y1 whole squared, and that is, so basically then I call it just simply AB, although there is no A or B here, but you get the idea. So the square root of, I take this as 1 and 2, so x2 minus x1 would be 2 minus m over 1 plus m minus or plus 1 whole squared plus y2 minus y1, so 5m plus 2 over 1 plus m minus y1, which is basically minus 2 whole squared, and you want to take the square root of this whole thing. Then we can simplify this a little bit. We can write this as basically the square root of 1 plus m, 2 minus m plus 1 plus m whole squared plus 1 plus m, 5m plus 2 minus 2 minus 2m whole squared, and take the square root of that. And what you need to do here is basically just a little bit of simplification. So over here you have basically m and negative n will cancel out, and then you have 2 minus 1, which is equal to 1. So 2 minus 1 is equal to 1, 1 over 1 plus m whole squared plus basically 5m minus 2m is equal to 3m, and these two will cancel out, 3m and over 1 plus m whole squared. So you have, what you have over here is the square root of basically 1 over 1 plus m whole squared plus 9m squared over 1 plus m whole squared, 1 plus m whole squared, 1 plus m whole squared, and then you can write this as basically the square root of 1 plus m whole squared, 1 plus 9m squared, which is basically a squared there is some way to simplify this, but and of course you know that it's equal to 3 units, so this is equal to 3 units, and so I can write 3 is equal to basically the square root of, and of course you can simplify this. 1 plus 9m squared is equal to well, you know, you can write this as, of course I'm not really sure if that's the right or necessary thing to do, but you can write 1 plus 9m squared, you can write it as 1 squared plus 3m whole squared, and now you can think of this as a squared plus b squared. Now a squared plus b squared is the same thing as you know, a let's not do this for now, and we will take care of it if we have to. I'm not really sure if we have to do this. So I write this as the square root of 1 plus 9m squared. Write this as the square root of 1 plus 9m squared, because, well, I think there is no way to simplify this. And I write 1 plus m whole squared. I write it the absolute value as of 1 plus m, just to make sure that it's not going to give me any negative values, because we are dealing with this with a distance over here. And so what that means is that basically you have it's easy to solve this equation, meaning that I can cross multiply 3 times the absolute value of 1 plus m is equal to the square root of 1 plus 9m squared, and then I can basically raise both sides of this equation to the second power. I write basically this raised to the second, if you raise this to the second power, since this was supposed to be a positive value, so you can just write it as 3 squared times 1 plus m whole squared without worrying about anything. And this is also was a positive value, so 1 plus 9m squared whole squared. And I suppose I don't really know how I got. Okay. And then what you can do is that now you need to do a little bit of simplification, meaning that 9 times 1 plus 2m plus m squared is equal to basically 1 plus 81 m raised to the power 4. So 81 m raised to the power 4 plus 2 times, which is basically 2 times AB, which is basically 18 times m raised to the power 2. Okay, I think we can get somewhere with this equation without any troubles. So that's 1 squared, that is basically b squared, which is 81 m raised to the power 4, and then 2ab would be 2 times 9m squared, which is 18m squared. So I write this as 9 plus 18m plus 9m squared, and move these to the other side, negative 1, negative 81 m raised to the power 4 minus 18m squared. So then I have is equal to 0. Then I have negative 81 m raised to the power 4 now 9m squared minus 18m squared is equal to negative 9m squared. And then we have plus 18m and plus 18m, 9 minus 1 is equal to 8. So you have negative 81 m raised to the power 4, negative 9 m raised to the power 2. So these are taken care of, plus 18m, and 9 minus 1 is equal to 8, is equal to 0. Now to solve this equation, what you need to do is, well, you know, to solve this equation, normally you have to basically multiply this 8, which is the constant in this 4th degree polynomial, multiply this 8 by this 81, and then prime factorize the whole number, which is a whole lot of trouble. I don't have the time, nor do I have the inclination to do that whole thing. So what I want to do, I will simply find out the roots of this equation using a graph, and then use that graph in order to factorize this equation. Otherwise it would take me forever to go to solve this equation. And for the sake of simplicity, I just write it as 81 m raised to the power 4 plus 9 m raised to the power 2 minus 18m minus 8 is equal to 0. So I'm going to write so y is equal to, I'm going to write y is equal to 81x raised to the power 4 plus 9x raised to the power 2 minus 18 minus 18x minus 8. And you see that this equation is basically something like this, which goes, okay, so this is, I think, 3/4, and this is 1/3 and 3/4. I suppose this is 3/4 and this is negative 1/3. So let me use a calculator here. I don't really know how those people like Euclid and Newton and all of these people did mathematics back like 300 years ago, because back then there was no computers, there was no graph, there was no calculator, there was even no pen. So they must have had a really hard time. Okay, so 3/4 is the same thing as, no, this thing over here is 0.6667. Now this is something, this is a good skill that you could have, meaning that if you all of a sudden you come across such a number, how do you, I mean, right now I do need to be able to basically convert this number into a fraction, because otherwise I cannot solve my equation. So you have one such number over here, which is of course that this calculator or this graph, basically this graph software. There is of course a calculator working as the engine of this whole thing, and that calculator has of course rounded my number to 4 decimal places, and then the number has become 0.6667. Otherwise it must have been 0.66666 repeating, and so on and so forth. So you need to be able to convert this number into a fraction. And also the same number we have over here. So you have 0.3333. So and you can see that over here the last digit has become 7, and over here the last digit has not changed, because, well, when you want to round up, for example, these numbers over here, suppose that so it's 0.6667, what you see over there, 0.6667. This number has been rounded to 4 decimal places. The original number was, or has been basically basically some integer divided by some other integer, and basically as a result basically the number has been basically 0.6666666, and so on and so forth, repeating forever. The other number was, that you can see over there, is 0.3333, and that also has been some number like a to b, which has been basically 0.3333 repeating. So when you want to round this number, for example, to 4 decimal places, you take a look at the you take a look at this digit over here. Whatever that digit is, if that's greater than 5, of course, then or you have to basically, of course, take a look at this digit over here. Whatever that digit is, if it's greater than 5, then this digit becomes, then you round up, meaning that this digit, you add 1 to, you basically, this 6 becomes a 7, and then your whole number becomes 0.6667. If this number is less than 5, then of course the number remains as 0.6666. So now, since this digit has been a 6 over here, you've gotten a 0.6667 as the rounded number. And over here as well, this digit has been a 3, less than 5. So then the number has been rounded to 0.3333. So that's basically now the numbers that you have. Now you need to, based on this situation, you need to be able to get these fractions so that you can solve your equation. And I think I'm going to stop this video here, and then we will continue with this in the next video.